Hello dear learners, welcome back to our channel. I am Vandana Yadav, Department of Chemistry, the Bhopal School of Social Sciences, and today we are going to discuss concept of chemical bonding. In this we are going to discuss what is a chemical bond, types of chemical bond. In detail we are going to discuss ionic bond and as well as covalent bond. So the very first question is, what is a chemical bond? Can anyone tell me? Bond is basically the force of attraction which binds the atom together in a molecule. For example, we have seen H2 molecule, and H2 molecule is made from two H atoms. So each atom is having its own electron, and when they come together they form a molecule. So the force of attraction which is binding these two atoms together in a molecule is called a chemical bond. Going by the definition, it refers to the force holding the atoms together to form a molecule, and basically the force is electric in nature. Now you all know in chemistry we have studied atoms, ions, molecules. So atoms combine to give you a molecule, and the force which is giving you the molecule or the force with which the atoms are coexisting is the chemical bond. So moving on to types of chemical bonds. So we have first one which is ionic bond, ions, as the name indicate, ions. Second one is the covalent bond, coexisting with each other. Third is hydrogen bond, and fourth is metallic bond, because metals cannot be explained on the basis of ionic and covalent. So we have a special kind of bond which is called a metallic bond. Going with the difference between them, ions means you will be having positive and negative ion. Covalent means sharing, or you can say ionic means transfer of electron. Covalent means sharing. Hydrogen bond is a special type of bond, and when we are discussing about bonding in metals, we have a special kind of bond, metallic bond. We are also going to discuss this covalent bond further exists into two types of two subclasses, polar covalent bond and non-polar covalent bond. So let's start with ionic bond. So ions, ionic bond, as I have shown you magnesium oxide or potassium dichromate, nickel 2 oxides. So whenever you are forming or you are combining a metal and a non-metal together, they are going to form an ionic compound. You all are regularly using NaCl. So NaCl is an ionic compound, and the bond between Na and Cl is purely ionic bond. Now the question is how they are forming NaCl, or what is the criteria. So as you can see, there is transfer of electron which is giving what? Which is giving ionic bond to you. So electrostatic force occurs between these two ions. Let's discuss this in detail. So you can see we have two Na and two Cl2. So what is happening during this process? Na, this arrangement of electron, it loses its electron and gets converted into positive form. So therefore we are writing it as Na positive, whereas on the other side chlorine is gaining an electron, and from 17 electrons now it has 18 electron. So these two are basically undergoing exchange, or you can say acceptance of electron. Na is giving electron to Cl to complete its octet. As you know, we have an octet rule that every atom tries to attain the noble gas configuration. So, in this process Na transfer one of its electron to Cl, and there is a bond which is purely electrostatic in nature, which give rise to a compound which is NaCl, and this is called the energetics of ionic bonding. So, ionic bond occurs by the formation of ion. The one which is losing the electron is the positive ion, and the one which is gaining the electron is the negative ion, and therefore we call it as ionic bond, which is occurring purely by transfer of electrons. Transfer of electron. Now, let us have a look that, as I told you, this also explains the octet rule. What is the octet rule? Octet rule says that each elements tend to either lose the electron or gain the electron. Why they want to gain the electron? They want to acquire a noble gas configuration. So, sodium, by giving away one electron, is becoming nearer to noble gas configuration, and chlorine, by gaining one electron, acquires 18 electron, which is an noble gas configuration. So, this phenomena of formation of positive and negative, or you can say the transfer of electron, clearly explains the octet rule. You can have a look at the ionization energy, that sodium, when we are removing its one electron, or it is transferring its one electron and getting converted into Na positive, it is 495, not very high, but you can see that the second ionization energy is very high, because here when you are trying to remove an electron from Na positive state, then it is almost nearer to noble gas configuration, stable configuration. So, you have to put in more amount of energy to remove one more electron. Therefore, you can see the second ionization energy are very high. Same is the case you can observe in case of magnesium. So, this phenomena of transfer of electron from one atom to another atom clearly explains the octet rule. So, we can say that ions or transfer of electron is occurring to acquire a noble gas configuration. Now, we are going to discuss the second type of bond, which is a covalent bond. So, as the name indicates, covalent bond. Covalent means you can say that sharing of electron occurs. You have one, I have one, and we both are going to share an electron, and we are going to form a bond. So, as you can see, the simplest example is H2 molecule. I have already discussed this, that H atom both are having 1s1, 1s1, and now to form H2 molecule, they are just sharing their 1 electron. So, such type of bond is called covalent bond. So, as you can see from the diagram, we have unpaired valence electron in first atom, and we have unpaired in second atom. Both of them are sharing their available valence electron, and they are forming a bond which is called a covalent bond, and the molecule is called covalent molecule. Okay, so basically the electron which you are sharing, they are called valence electron. So, covalent bond means whenever we are having one electron and we are ready to share among themselves. Now, you can see I have shown you 3 examples of covalent bonding. So, here in the first example, we have water molecule. Water molecule is basically having 1 oxygen and 2 H atom, but you can see that I have put a small positive charge on both the H atom and negative charge on oxygen atom. While in case of CH4, this is example of methane, CH4, you can see I have not put any positive and negative sign, and same is the case with O2 molecule, I have not put any positive and negative sign. So, this give rise to 2 types of covalent bonding, that is a polar covalent bond and a non-polar covalent bond. So, we are going to discuss these in detail. So, let us move on to polar covalent bond and non-polar covalent bond. So, before moving on to polar and non-polar, just remember one thing, covalent bond strength. The strength of the bond is basically determined how much energy is required to break it. So, in order to break a particular bond, or especially when we are talking about covalent bond, you have to put in some amount of energy which is called bond enthalpy. This is called bond enthalpy, and for example, I have taken Cl, you can see they are also forming a covalent bond. So, Cl is having around energy 242 kilojoules. So, 242 kilojoules, or you can say this is the bond enthalpy for Cl bond. This much amount of energy you have to put in to break the Cl bond. So, covalent bond strength can be measured from bond enthalpy. Now, moving on to our topic, polar covalent bond. So, polar, poles, from the word you can clearly see poles, two poles. We have studied in physics north pole and south pole in the magnet. So, covalent bond, I have shown you two examples. We have F2 molecule and we have HF molecule. You can see that F and F covalent bond sharing can be equal or it cannot be equal. By equal and not equal, I want to say that if I am having same type of atom which are sharing their electron, okay, so they are basically having same electronegativity. So, their pulling the electron to the same extent. However, you can say that in case of H and F, the fluorine end has more electron. You can see the fluorine end is having more electron and the H end is having lesser electron. Okay, but now how you can say that fluorine is pulling harder and hydrogen is pulling to a lesser extent? This can be explained on the basis of electronegativity, which give rise to polar covalent bond. So, greater is the difference in the electronegativity between the two atoms which are combining, you can say more polar will be the bond. So, as you can see, I have shown you that H and F, fluorine, you all know, halogens, they are electronegative and hydrogen is not that much electronegative, or you can say they have a wide difference of electronegativity. So, hence there are poles being developed when you are forming covalent bond or whenever they are sharing the electron. What does poles mean? The two bonding electron pairs lies more towards fluorine, because fluorine due to more electronegativity pulls the electron towards itself. So, from the table you are clearly having the idea that if I compare the electronegativity like HF, HCl, HBr, HI, all of them are basically having one valence electron. So, they are doing what? They are sharing or they are forming covalent bond with H. So, you can see that bond length in each case, electronegativity difference, and you can see the dipole moment. So, greater is the difference in the electronegativity, the more polar is the bond. So, from the data you can see that HF is having greatest electronegativity difference, which is around 1.9, and HI is having least. So, in this case you can see I have shown with the colors also that F and is more of red because greater electronegativity difference, which give rise to a category of covalent bond which is called polar covalent bond. So, whenever two different atoms combine or they share their electron, they give rise to a covalent bond, but based on the basis of their electronegativity, we can say that they are forming a polar covalent bond. So, this I have shown you in respect of this. So, in water molecule also I have already shown this, but in water molecules also you can see that oxygen being more electronegative than two H atoms. So, electrons pull towards oxygen and water molecule is also polar. So, anytime there is, you should remember this point, that there are unshared pair of electrons on the central atom, the molecule will be polar in nature, and if they are forming covalent bond, then that bond will be polar covalent bond. So, therefore, we can say that our water is what? Our water is polar in nature. So, understanding polar and non-polar. See, there are two terms, polar and non-polar molecules, polar and non-polar bonds. So, if we talk about polar molecule, so you should know that polar molecules are asymmetrical, or central atom, like in the case of oxygen, it is having unshared pair of electron. When we talk about non-polar molecules, then we are having symmetrical, like if I am talking about H and H, symmetry is there, you can see Cl, Cl, symmetry is there. And when I am talking about bonds, then you should know, or you should remember the electronegativity difference. In non-polar, the electronegativity difference is almost negligible, but in polar there is certain value for electronegativity difference, which give rise to what? Which give rise to small positive and small negative charge. So, this is the basic idea and basic concept which you should remember while studying polar and non-polar structures. Moving on to non-polar covalent bond, as I have already told you, non-polar covalent bond is formed when electrons are shared equally, or you can say when our electrons are shared between two same types of atom. So, non-polar, the difference of electronegativity is almost negligible. As you can see, I have shown you the example of H2, H and H. So, that is the sharing, and the electronegativity difference, you can see there is no electronegativity difference because both of the atoms are same. So, these give rise to a covalent bond which is non-polar in nature because there are no poles developed. So, I think you are clear with polar and non-polar covalent bonds. Average bond enthalpies, just an idea that average bond enthalpies, in this case you can see they are positive. So, basically you have to put in amount of energy to break the bond. So, all these show that it is an endothermic process. Next you can see the bond length. Bond length is that covalent bond sharing can be for single bond or a double bond. As you all know that we have unsaturation also. So, whenever you can say oxygen is forming a double bond with another oxygen. So, this is also a covalent bond, this is also a covalent bond, but you can see the bond length of single bond is 1.48 and double bond is 1.21. So, as the number of bonds between two atoms increases, the bond length decreases. So, this is clear from this data. You can also see in this case, you can also see in this case. So, bond length are, you can say, an average bond length gives an idea about the strength of the bond. So, I hope you have clear understanding about basic concept of chemical bonding. We have discussed in detail ionic bond and covalent bond. This is all from my side in this lecture. Happy learning. Thank you.